Right, so welcome now to part 2. So now that we've seen that this is approximation, let's get on with the problem and see if we can check if this solution is even in equilibrium. Okay, so let's check if this is in equilibrium, but I want us to follow the steps of going from the displacement field to the strain. The strain gets mapped to stress, and those stresses we can then check whether it's in equilibrium. So let's get on with it. So let's get the strain part going. So I'm just going to write here, this is now part 2 of the video. So that is just clear. Okay, so let's just write down our strain 6x1 vector. We know it's symmetric, so we're not going to write everything down, just the 6x1 component. So this is epsilon xx, epsilon yy, epsilon zz. And then I just want to make sure it's order in the, it's gamma yz, gamma xz, and gamma xy. So I just want to keep it exactly the same as in the textbook. Okay, so that is what we have. And as a reminder, what this is partial u, partial x, yeah, partial v, partial y, partial w, partial z. This is then essentially partial v, partial z, plus partial w, partial y, partial w, partial x, and partial u, partial z, and this is partial v, partial x, plus partial u, partial y. Okay, so that is essentially what we have. So all that we should do is now compute these partial derivatives of a field that's given to us. This is really just basic mathematics that we're going to be doing. Okay, so let's just, what I want to do is just quickly check if I'm off on the board. I'm going to just start writing, and then I realize I'm, okay, what I do see is I'm not off, but I am seeing that I'm not clear. Okay, so that is way better. Okay, so let's just make sure I write these so that they're a lot clearer. Okay, and this side, also unfortunately this is not, didn't come out nicely, but that should be a lot better now. Okay, so that is clear. I'm going to make sure I get the end in there, so that also is clear. Okay. Aye, this is now always a surprise if you write a little bit too fast with them. Okay, so that is a lot better. Okay, yes, today. That's a lot of ink coming out at the back. Okay, so let's go. So this is essentially epsilon xx. Partial derivative of this with respect to x is just t over e. Okay, if there were any other terms, in terms of, let's call it y or z, so I'm going to just, for illustrative purposes, just explain this to you so that I can just make sure that everybody's comfortable with what the partial derivative is. The partial derivative, we're going to imagine that all the other variables in this expression are constant. So if they were, so this is not what's in here, but I'm just going to give an example. If there were an x, and a z and a y in here, for instance. Oops. If there was a z and a y in here, and I were to take the partial derivative of this u with respect to x, I take this term, I see there's an x there, so I differentiate it, and if there was any x and y, or z, y and z, I would just imagine it to be constant, so I get this t over e out. And if I get to this term here, and I take the partial derivative with respect to x, I treat them as constants, so they will just disappear. So that is essentially what that boils down, so that they will evaluate towards 0. Okay, so that's just important to take note that we're all comfortable with partial derivatives as a quick recap. Okay, so if we get to the second expression, for this strain in the y component, I need to take the partial derivative of this expression with respect to y. So this with respect to y is just minus t over e. And if I take this expression with respect to z, that's what I need to take. I'll get this minus t over e. Okay, so that is fantastic. And now I can complete the shears. So now I can get to essentially to say, let's start with this one. So I need to take v with respect to z. So this with partial derivative with respect to z, there is no z in here. And so essentially this term just evaluates to 0. If I take this w with respect to y, it's also 0. Okay, it's only a function of z. And then if I go on, I can go through this step by step and say this now with respect to x is also 0. There's no x in that expression. The positive of u with respect to z is also 0. There's no z. And then the last one evaluates the same. So that's essentially our strain field that we have. Okay, so that strain field then we can now take forward towards stress. So I'm going to pause the video here and we'll do it as part 3.